Good afternoon. I wanted to follow up with another example that could be used to help support your assignment this evening. Here's a quick picture of the example we went through today. And then I'll go ahead and take a look at the next class example to kind of help reinforce this whole idea a little bit. I'm going to do it pretty quickly. That way if you come in tomorrow, if you have some more questions, we can handle those together in a smaller group. Our first thing I would probably address, I would look at this and I would say, is it continuous or discontinuous? It is continuous, meaning from the left side of this graph all the way to the right side of this graph, we never need to lift our pencil. So that is a continuous graph. Generally that makes domain and range a little bit easier. Okay, our domain is limits on x. This has an arrow on the end. Okay, an arrow on this end goes all the way to the edge, so that kind of confirms that. Has nothing missing in between. So basically our domain would be everything from here to here infinitely. So it would be negative infinity to infinity. Our range is our vertical. So we're talking about the bottom of the graph to the top of the graph. Now in this case, the top of that graph, the bottom peaks out, or basically drops right there, but the top actually goes infinitely because it had an arrow on the end. So it's basically the bottom y value is -1, and it is a closed circle down there. And the upper y value is infinity. And we never reach infinity, so there are always going to be parentheses. Okay. Next, we're going to look at increasing, decreasing intervals constant. Okay. I can look here. I don't see any values where it's constant, so I'm just going to go ahead and write in none. I generally work from left to right, so I'm going to start and I'm going to say from negative infinity for x to x equals 0, it is decreasing. So I'm going to say negative infinity to 0. At 0 it's changing, so I'm going to leave parentheses. Then from 0 to, I'm going to say about 1.5-ish, okay, it's increasing. So, and there it's changing on both ends, so I'm going to say 0 to 1.5, and I am estimating. Okay, and then it's decreasing all the way to here, about 4.5. So I'm going to say from, we're going to union these answers. I'm going to say from 1.5 to 4.5 it's decreasing. And then from 4.5 roughly to infinity, okay, I really don't know what it's doing there. Is that a sine curve? So I'm going to say, we're just going to leave it there at the end, and I'm going to say union. It's going to be increasing 4.5 to, if assuming it keeps going like so, I'm going to say to infinity. Okay? Now, somebody could argue with me, is that a sine curve? Well, I don't know that for sure. If it's a sine curve, then we're going to continue to have these oscillating values, increasing, decreasing. I'm not even going to focus on that right now. We're going to assume it just goes on infinitely and it's some kind of cubic function instead. Okay? Maximum, minimum values. Remember, local means just within its own region. Local and relative were the same thing. Absolute means it's an absolute max. I'm just looking for these values. So I'm going to choose my locals and absolutes. We have right here a change from decreasing to increasing, so that is a minimum. So my minimum is y equals 0 when x equals 0. Okay, I have another minimum right over here at, we decided earlier it was about 4.5 at -1. So y equals -1 when x equals 4.5. All right, we have a local max right here at about 1.5. So, x is 1.5, so I'm going to say y. We have a maximum when y is 1 at y is 1 when x is approximately 1.5. Okay, so that is basically going to help support hopefully some of the problems you might have had on the assignment. Hopefully you'll be able to get everything that you can from the assignment coming in tomorrow, and we can clean up some details. Have a great evening. 5.5 minutes, not bad.